Hello and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 93,000 computing professionals and students members. International conferences. Oh, okay. I'm Erik Meijer. I'm a language geek that worked on various languages like Haskell, Hack, and of course I am the inventor of Rx, which will play a big role in this talk today. For those of you who may be unfamiliar with ACM or what it has to offer, educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. Highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. For example, ACM provides information published by ACM, including CACM and Q magazines, access to the ACM Digital Library, the world's most comprehensive database of computing literature, conferences that draw leading experts on a broad spectrum of computing topics, and support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize in Computing Awards. Members to solve critical problems by using new technology that enriches our lives and advances our society in the digital age. With the presentation, I'd like to quickly mention a few housekeeping items also shown on the slide in front of you. Advance automatically throughout the event. On the bottom panel, you find a number of additional widgets and resources. If you have problems with the slides or audio, press the F5 keys in Windows or Command R if you're on a Mac browser on a mobile device. Of course, you can always relaunch the presentation. Volume, adjust the master volume on your computer. If you have questions during the webinar, type them into the Q&A box at any time. I'll organize a question session as Pat Sissons speaks, and he will reserve time to address and answer them. Recorded and will be archived. You will receive an automatic email notification when it comes available. Check learning.acm.org for updates of this and other upcoming webcasts. At the end of the presentation, you'll see a survey up on the screen. Please take a minute to fill it out and help us improve our webinars. Survey at any time during the presentation from the menu dock at the bottom of your screen. You can also use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using hashtag. We'll be watching for your tweets. We also have a new community discourse page to continue the discussion after the webcast, including questions we won't be able to get through. You should be seeing a window open in a new tab of your browser now. You can bookmark it and return to it after the presentation. Is Monadic programming for the web using React and RxJS by Pat Sissons. Is currently a senior developer at Marine Learning Systems in Vancouver, BC, Canada. He has been developing software for more than 10 years, focusing heavily on C# in the early years, to portable libraries and Xamarin later on, branching out to front-end languages more recently. Technology enthusiast with a passion for understanding how things work. He loves learning new software libraries and languages and keeping up with the latest trends in software, hardware, architecture, and distributed systems. Pat, without further ado, take it away and show us the Monads.
All right, welcome everyone. I am going to talk to you all today about webrx-react, and you can follow along if you would like, and otherwise you can watch this webcast, and I will get things started in the next few moments with who I am. So as Erik mentioned, I am a senior software developer at a company in Vancouver, BC called Marine Learning Systems. You're welcome to take a look at some of the things I've done on GitHub and some of the things I've posted to our Marine OS GitHub team. So let's talk about webrx-react. webrx-react is a project that Marine Learning Systems commissioned for me to produce a front-end framework that would use RxJS and React to combine together a simpler way of developing front-end web components. I ended up choosing to do it in TypeScript just because I am a fan of typed languages, and I thought TypeScript was a very interesting new language concept. And really our goal was to take advantage of the efficient rendering of React and use RxJS as a method of driving those efficient renderings. So what is Monadic programming? I'm not going to go into a huge depth of explanation on what Monadic programming is, but at the surface level, it's state encapsulation, functional mutations of that state, and chainable operations for the monads. In webrx-react, we use RxJS as our monadic system. So our monads are observables. RxJS is, and Rx in general, defines the observables as a contained unit of operation that is capable of asynchronously producing results based on input sources. So we use that to interact with asynchronous event management, which can be DOM events or other programmatic events. And with RxJS and the whole Rx ecosystem, you get for free a very large library of operations to mutate and transform your monads. And because it's ported to so many different languages, such as Python, C#, Java, Ruby, I could probably name off about 10 or 15 more. Because it's ported to so many languages, if you've ever learned it in one language, it's very easy to transition to another language. So while I'm not going to be talking about any of the other languages, RxJS is not my first Rx language. It was originally in C#.NET, but because I had learned it previously in C#.NET, the transition to RxJS was very seamless. So just a quick overview of how this RxJS stuff works. I'll just do a quick coding example here. So we're using our RxJS to create an observable that is a timer that fires an event every 5 seconds. We want 10 of those events before we kill the stream, and we're using the map operation to mutate our observable events into a random number between 1 and 5, and then we're projecting that 1 to 5 into another result that's going to be a JSON object that is the result of actually performing a secondary, second-level observable request through an AJAX call. In RxJS, in order to actually get the observable stream to do anything, you must subscribe to it at some point. And so that's what we do at the end. We subscribe, and then we have now a functional block that allows us to extract the result of the execution of this observable stream. Just a note too, you'll see at the top, if you actually are following along, there are some live demos that you may click. And they will take you to just a sample execution of these examples. So I took a few ideas from WPF, which is the C# view composition language that came with .NET, and a library called RXUI or Reactive UI, written by Paul Betts. which are both doing roughly the same thing. They are taking monadic development using Rx and applying the MVVM pattern to it so that we can use data binding between the view and the view model and view templating on the view rendering side. We use the Rx system to produce special constructs called properties and commands. Properties serve as a structure that contains mutable or sometimes one-way bound state, and then the commands are designed as a sort of sink for event management. So we use commands to possibly pull in data from the user or from external events. And finally, through these two constructs, we use a special custom observable operator called whenAny. And whenAny, which I'll talk about in more detail in a moment here, allows us to combine multiple properties and commands and just observables in general into more complex observable streams. So to achieve these, the whenAny, the properties and commands, I was using a library called webrx for the early stages of this library development. And this library, while it is not actively developed anymore, the developer has abandoned it in favor of Vue.js because its original intent was to be a full-featured reactive web development framework, including its own rendering engine and everything. And I was particularly using the small parts of it that were providing the reactive object framework. And so I ended up porting this, which is essentially a rewrite of the entire framework of the parts that I was using to produce my own internal reactive object framework. And by doing this, I reduced the footprint probably by about 90%. It is extremely modular compared to the old one where I was pulling in basically the entire library just to get a small portion of the webrx library. And because this is now written with an updated code base, I gained support for some of the newer TypeScript 2.3x features, which have been numerous since when the webrx was originally written, which I believe was for one of the very early versions of TypeScript. And now we actually get to take advantage of RxJS 5, which is a complete rewrite of RxJS 4, and RxJS 5 has been shown to be very performant in the rewrite. Finally, I was also trying to get a closer approximation to the RXUI reactive framework in my rewrite, which helps to simplify how the whenAny operator is actually working. So in developing the properties and commands, we have two types of properties. All properties are actually observable sourced, but some are, the observable source is produced automatically, and sometimes the observable source is passed in as a parameter. So in the parameter variant, we're actually creating an observable property by giving it an observable that will dictate what that property's current mutable state is. In the two-way bound property variant, we are actually creating a property possibly with an initial value, and then we are then able to control what that value is. And so this allows us to essentially have for example, a text field where we can type in text, and that text being typed in is then bound directly to this property. And any changes to that property also get reflected in the actual text. And then for commands, we can either have observable source command execution, which would be creating an observable stream either through whenAny or just creating an actual observable discretely. and then telling that observable whenever it fires to additionally execute a command execution. And so that will actually essentially be a very lightweight wrapper around a subscription. And then we also have DOM event command execution, which is essentially a view-bound command execution. And in this case, we have views that say like a mouse move or a hover or anything like that can then, any type of DOM event can invoke a command on the view model side. In order to get data into the system, we have an observable web API, which is essentially a wrapper around observable.ajax. And observable.ajax is just a observable function that allows us to perform an AJAX call and then interpret the results of that asynchronous AJAX call as the observable result. The best way to think of it is a one-time observable an observable that will fire exactly once, or 0 times if there's an error, but generally observable once. And so we use this to get data out of a external data source, and additionally post modifications to an external data source. The best part about the Observable API is that it's asynchronously composable. So we can actually use this as part of our stream compositions in more complex observable streams. So here we have the same example as we had previously, although the difference is that we are now using the Observable API, and really you can see that the Observable API is just a very simple wrapper around what we were talking about before with observable.ajax. We're providing it sort of a root or base URI, and then we are then calling either get observable or post observable, and passing in get parameters and body parameters. We still have the same structure to the observable stream and the same subscription. I added the error handler as well in this example, but it could have been in the previous example just the same. So when we're composing observables with whenAny, we are essentially using the observable operator called combineLatest. CombineLatest is a very powerful operator that supports combining multiple observables into a single observable projection. The reason why it's so powerful is that it will wait until all observables have at least fired once, and whatever the latest value of each observable is provided in the projection function. What whenAny does over and above this is that if we pass in any of our parameters as properties, observable properties, these properties additionally produce an observable using the start with operator, which essentially it seeds the observable combineLatest operation so that we initially get our projection immediately. This is very convenient for creating observable streams that we want to basically create a one-way sourced observable property that has an immediate value. So now that we have all the observables and observable stream composition out of the way, we want to use React as a monadic rendering engine that will render some view components to the browser based on observable components. So React itself, it uses read-only component attributes and read-only snapshots of the mutable state to perform a declarative template rendering. And this declarative template is just essentially HTML that we can inject our own observable values into it based on the current snapshot of that state. And we use our observable results, any number of observable results that we have composed, to invoke this rendering. So a quick React demo, just to describe sort of how we would use an observable to generate a re-rendering of a React component. Here we have a timer that fires every 2.8 seconds. And then every time that timer fires, we update the React component state with we are appending increasing and incrementing the counter, which is the counter is our actual state, as we can see in the constructor. Every time that this set state fires, we actually, the React system will call render, and we will recreate this component. And React does its own internal magic to prevent re-rendering anything that hasn't changed. And so what we're actually going to find is only the H3 tag is actually ever re-rendered, and that's just due to the way that React actually works. So by doing all this, what webrx-react is actually doing is it's splitting up this sort of observable side and the view side. And so our observable side are the view models in the MVVM pattern. So really all these are containers for properties and commands. We have some lifecycle injection functions in case we want to do any additional processing at certain lifecycle points. However, the majority of all stream composition should be occurring in the constructor itself because we are declaratively describing behaviors in the constructor. These view models can also consume routing state. Routing state allows us to use the routing system of the browser to inject certain state elements into the view models. And these state elements are themselves also observables, which can be composed into observable properties and command executions. The view models also have a few extra injection points to use some of the more higher level features of the webrx-react system, such as the global search and the page header menu item injection. On the view side, we have basically a wrapper around the React component class. We essentially provide a component property interface description, and then our state is actually going to be the view model itself. The React lifecycle injection functions also exist on the view. These injection functions are themselves also passing down into the view models, and that's what I was talking about with the view model injection functions. And then we have view model component bindings, which are essentially our way of tying in certain view components to a view model observable property or observable command in certain cases. And so all of our views updates, that render call, are driven by one or more view model observables. And there is a update on function in every view, and this function returns an array of observables that should be composed together inside of a combine-latest, i.e. a whenAny operator that will additionally perform some rate limiting and finally subscribe and call a special function on React called force update, which essentially is a no op of set state, but it performs a re-rendering of the view. So here is a very brief component demo. This is an example of a toggle button, how you might implement one. So we have a command that is essentially the toggling of the button. So that would be the click event. And we have our enabled or disabled state, which is simply using an observable composition based on the results of toggle executions. We're setting our initial value of enabled to false, and every time that toggle is happening, we're just flip-flopping that state. So on the view side, we are telling the React system that we want to drive all renders on the state enable changed property. And so changed is a special observable property on all observable properties that is essentially an observable representing whenever the value changes, and not just not is attempted to be changed, but is legitimately a different value from the previous value. And so whenever that observable fires, we will call our render function. And in this case, we're just going to fetch our actual our state enabled value, which is whether or not this function is enabled. We use class names, which is a dependent module in NPM, to create a enabled CSS class on this, and then we would style the button appropriately to visualize whether or not this button is enabled or not. And finally, we bind this command to the toggle command in our view model, so that whenever it is clicked, we will actually re-render this entire thing, this entire view. And so we additionally have this props children, which is just a React way of doing composition. And so that means that we can actually inject any further content we want into this component. And this would be, for example, adding text to the command as a very crude example. So with webrx-react components, I have built a component library that sort of provides a very simplistic way of combining very common styles of development for the web. So I have a few listed here. These are all based on Bootstrap 3, which is using a library called React Bootstrap, which is simply a React wrapper around the Bootstrap 3 component library. Some of the popular ones are bindable input, command button, which you saw in the example previously. Data grid and item list are very powerful for rendering lists of data. And then we have modal dialog and context menu, which are very easy to use browser overlays, which have typically been very complicated things to actually achieve in browser-related development. So I'm just going to go through some quick examples of these common components that I just described. I won't go into too much detail on these because there's a lot of text on some of these, but I'll kind of describe briefly what the examples are actually doing. So in here, we are actually using a bindable input, which is designed to bind directly to a observable property. And these observable properties are then automatically updated whenever the related input, DOM input element is changed. And so we can actually use these for any type of input element in the DOM. In this case, I'm using a form control, which is essentially just any type of input. And in this particular case, it's a text input. But we could easily use this with a checkbox or a radio button or anything that has a DOM element that can be mutated in the DOM. And so basically, we're just taking those DOM mutations and automatically applying them into our view model onto a property. And in the command example, we're just doing the exact same thing as before. All command buttons also have a command parameter, which we can then actually derive at the time of execution, and this allows us to inject UI or view model state into the command execution. So the data grid and item list panel, these guys are very similar. An item list panel is simply a wrapper around the data grid view, and they both provide a declarative way of rendering lists of data by defining the columns of that data and how those columns should be rendered. So in the first example for data grid view, we have a very simple column definition where we're just rendering the ID property on the currently active element. And then in the second example, we have a slightly more complicated column render template where we're actually specifically composing multiple model elements into a single a string in this case. The way that an item list panel view differs from a data grid view is that we additionally have a bootstrap panel wrapping around the whole thing, which provides us access to header content, footer content, header actions, footer actions, and additionally some teaser content, which allows us to sort of have these various injection points to render additional content in a very consistent manner. Finally, all these data grid columns also can provide a tooltip overlay by simply extending the tooltip property on the data grid column. We can apply tooltips to either the view or the column header or the column itself, just by detecting whether or not we actually have a row element to deal with. So you can see in the example here, the tooltip is actually checking to see if our row element is null. If it is, that means we have no data for that row, which means we're rendering a tooltip for the header. Otherwise, we're rendering a tooltip for the row element. All right, so let's go to the modal dialog and the context menu. These are very simple ways of rendering a modal overlay. The React Bootstrap library is very powerfully handling all the behind-the-scenes mounting and unmounting of DOM nodes for these overlays. And all we have to do is basically define, in the case of a context menu, is what is the structure of it. So we have a div representing the header for the actual content of the context menu, and then menu items following that will simply handle all the menu items, and we can then use onClick to actually bind these menu item clicks to a view model command. Additionally, we can also just use the onClicks to perform additional UI-only logic if we needed to. And on the modal dialog side, we actually use a modal dialog view model, which provides us a little extra horsepower to understand when these modal dialogs should be visible. And we are capable of providing to it the command buttons that will show up in the footer of the modal so that we can actually define what types of actions this modal is supporting. And we actually have a special function on the modal view model called hideOnExecute, which will automatically execute the parameter function, but additionally hide the modal at the same time if the command execution is successful. Okay, so here we come to a new component that I haven't talked about yet. This is the route handler view. And the route handler view is actually designed as a method of rendering whatever the route manager, which I'm about to talk to in a moment, whatever it's deciding is the currently active view model component. So the route manager will tell us what is the routing state and what is the routed path. And we use a routing map, which is using a regular expression to define a routable component with a routed component activator function. So these are how we create the actual view models that are to be rendered. And we use a view map, which, and by the way, there's actually a typo in this slide example. Demo in the view map should actually read demo component view model. The view model view map routing is actually just creating a mapping between the name of a view model and the component that we should create, which doesn't even have to be directly the view itself. It can be a wrapper around that view if we actually wanted to. Whenever we are creating a new view map mapping, we actually are provided the view model that should be used in the composition, and that's how we actually compose all of our view elements in the route handler. So the route handler itself is just a simple React component that we provide the route handler view model and our view map, and it will happily monitor the route manager for all routing changes and then render whatever the routed component is, and if there are none, it will render a default error message. So the route manager is a special, it's a non-React or view model class. It is this simple class that basically uses a hash-based routing state, and it leverages the browser history API. If it is available on older browsers, it is not available. So in these cases, we can fall back on hash changed. Both will provide full routing capabilities. However, the browser history API allows us to ignore routing events for very quick changes, perhaps if you are performing redirects or if we're performing in-component routing state changes, whereas the hash change is a very basic system where any change in the routing hash will actually generate a new navigatable state. Our routing state is actually decoded automatically by the route manager, and it was passed into the load routing state. And this routing state is actually fetched anytime there is a routing state changed event that happens in a view model, and that the routing system will then call a save routing state for the view model to create its routing state at that time. So let's move on to a canonical to-do list example. I have a few screenshots here, but I will do a brief live demo of what this actually looks like. So really what we have here is just a composition of a number of things. This is all sitting in a item list panel view. We have the item list panel view comes with a search view. We have a custom component that is acting as a two-way bound input with a command button that is bound to a view model add item command. And because our searches are regular expression enabled, we can actually type in very specific regular expressions to perform more advanced composition. We also additionally have a remove command and a toggle completion command for the checkboxes. So let's just switch over to the demo here. So here we have, let's learn webrx-react. And so what I'm doing here is I'm calling the add item command, and it's then generating a new item, which is then injected into the bound list for this item list panel, and then that's generating a re-render of the list component. So we can actually add as many of these as we want, and then we can remove these guys whenever we actually want. And so we can also toggle the status of these and put in a new one, fun. So now we can type in fun, but we can also go webrx or web. And so this is allowing us to actually automatically search. So all of this stuff is rate limited using the debounce function. in RxJS. And we make sure that we don't re-render things more often than we actually need to, because there's no point pushing all that data into the React system if we don't need to. This prevents thrashing of observable changes. So, consuming this library, it is published in NPM. It is available on the unpackage, which is the old NPM CDN. I believe that the unpackage bundle, the Uglify bundle here that I'm talking about, is actually not quite ready yet. But the modular imports for ES6 and TypeScript are what's being consumed right now by my projects at Marine Learning Systems. We do have IE9 support for all this stuff because it is all ES5 compatible. This is specifically relatable to why did I build this. The main answer is that we needed to build modular shareable components that we could reuse across multiple projects. We wanted very snappy, responsive, complex views that had a lot of data, that was mutating a lot of data, and we didn't want to pay the expensive cost of running it through Angular 1, which we had previously experienced a lot of performance issues with. And finally, we had some realistic constraints. Some of our clients were unable to upgrade beyond IE9, so we had to support some of this older stuff, which prevented us from using some of the newer libraries like Polymer. So on the roadmap for webrx-react, we have a first real release coming. There are still a few bugs being discovered here and there, so it is still technically beta. However, I can tell you that we're quite happily using and consuming this library and largely having zero issues with it. I would also like to extend at some point the view abstraction so that we're not relying 100% on Bootstrap 3. Bootstrap 3 isn't for everyone. It's perfectly fine way of getting content rendered in a responsive manner, but sometimes you want it to look different. And Material Foundation, the UI Fabric, and Polymer are all great libraries for getting this done as well. And it would be perfectly acceptable to abstract the view layer so that we could choose which rendering library we actually want to use. And with that said, this presentation is over. That is webrx-react. So I will open up questions from the floor.
Well, thanks a lot. There are a few questions. Let's start with the first one. And the question is there a reason the observable setup in component will mount rather than component did mount?
Probably, I assume you're talking about the example, and no, there's not really a reason. It could have gone in either. It was just probably I picked one of the two when I was writing the example.
All right, and then the second question is interoperability with other React view libraries like Material UI. Do you need to make custom bindings for each component?
Yeah, so that's basically what I was getting at in the roadmap. It is not very easy to use different rendering libraries, but I do want to provide that feature. I think it's very valuable, and at the time it was just a time limitation that we had to pick one, and we were currently using Bootstrap, so it made sense to start with Bootstrap.
All right, and then the next question is, can you explain the connection between Monads and WebRx?
So WebRx, if you're talking about the internal piece that I was using, the monads themselves are the observable properties and observable commands. And the monadic relation of webrx-react with React is that we are using compositions of these monads, these properties and commands, to drive the re-rendering of a React component. And so the difference between what we're doing with webrx-react and how you would normally do this in just regular pure React is that in pure React we would be performing logic which would then basically call a set state function, whereas in webrx-react we are describing the behavior and interconnections between these monads, between the properties and commands, and using that itself as the driver for the re-renderings on the React side.
Another question, is WebRx easy to get started for those familiar with MobX?
I have read about MobX, and it was also not available at the time that I started writing this. It sounds like a very interesting platform. I think that eventually webrx-react will be easy to get started with for those familiar, because the same concepts essentially apply. You're binding the view to the view model, and then you're using view model behaviors to drive the changes to your view.
Another question, how does it compare to libraries like Redux?
Yes, sorry, I forgot to talk about Redux. So I did briefly look at Redux as a state management system. The difference is that I wanted our states to be what I like to call smart states and more composable and modular. Redux kind of bundles all the state into one big giant state structure, and then uses some smart logic to change only the parts of that giant structure that are necessary. I wanted to contain all the state changes into a single unit that was the view and view model itself, so that those states were not actually interconnected.
All right, another question. What is your favorite Rx operator?
So originally, definitely, it was going to be the combineLatest because I use that a lot. Lately, I have actually been very happy with the scan operator because I use it a lot to build dynamic lists that are changing. I have used the scan operator to essentially produce a single observable stream that operates on list change operations, and those list change operations can be a reset to a new list, as well as a addition of any number of elements and a removal of any number of elements, and that allows you to essentially create a dynamic list that is composed as a single observable. It's very neat.
All right, next question. Monadic aspect, which is more important, React or RxJS?
RxJS is definitely the more important part to program monadically. React is just simply a observer of the monads and reacting to those monads by re-rendering views that are bound to the monadic values, or the monadic state, I should say.
All right. Another question is, in your daily workflow, how do you debug programs?
Sorry, can you repeat that?
How do you debug your Rx-based code?
So generally,
any errors?
Yeah, so generally when I'm debugging or when I'm developing a new component, I am using the browser's debug engine. The way that webrx-react is set up, and if you follow sort of the rough template that the library is using in GitHub, it allows you to run a Webpack development server, which allows you to perform live adjustments to components, and then using the browser's debug engine, since source maps are emitted with those the source that is generated by Webpack.
And do you like use any of the like marble diagram generators or anything like that, or when you reason about behavior?
I have used RxMarbles a few times, usually just to visualize for myself whether or not a more complex stream composition would make sense. For example, I've used it with latest from operator just to make sure that the composition will make sense. But I don't actually use RxMarbles like day to day in development.
State using Rx across components as easy as with Redux?
So you can share state. There is a pub subsystem that allows you to share state across disconnected components. However, in general, if you need to share state throughout a parentage hierarchy, what you're going to want to do is basically pass down the state that is required for each component. So you're essentially composing these multi-level components that will then consume child state from the parent state.
Last question. Do you envision some deeper connection between webrx.js and GraphQL beyond just firing an API call?
That's a very good question. The answer is I don't know yet. The WebRx, I did briefly look at GraphQL, and I didn't see an immediate use for it in this system. However, I can totally see that there is potential there for using GraphQL, but I didn't have an immediate use for it, and so I kind of didn't bother exploring that in more detail. Perhaps in the future, I can actually explore that a little bit further. But for the time being, mostly due to time constraints, I haven't had a chance to really explore it in a meaningful manner.
All right. Well, thanks so much. I am afraid we have run out of time, but don't forget that the discussions continue on our discourse page earlier. If you don't see it, you can access it now through the link in the resources window. Thanks so much, Pat, for your informative presentation and your answers to the questions. Especially
thank you for having me.
All right. And also remember the webinar was recorded and will be available online in a few days at webinar.acm.org, and announcement about upcoming and webinars and other ACM activities. Think about, remember to kind of like fill out a quick survey where you can suggest future topics or speakers. And on behalf of ACM, Pat Sissons, and myself, Erik Meijer, thanks again for joining us again in the future. This concludes this webinar, and talk to you soon.